Okay, sorry. For some reason, I think my little pen hit the stop record button. So here's the continuation. Okay, so this bison question. So here's the thing, everyone. This is kind of a chain rule in disguise. So the most important, well, there are several things, but x and y are functions of t. Okay, so let's make sure we understand that yes, h is a function of x, y, and t, and x and y are also functions of t. Okay? So at the end of the day, if you look at what we've got here, dh dt, right? If you think about how this chain rule works, at the end of the day, when you look at dh dt, this is the branch, these are all the branches of this tree. So this branch is right here. This branch is right here. And then, of course, this is kind of neat. Look at this one. I'm running out of colors here, but this is just this path right here, right? Because T ends, this three branches coming out from H, this third branch of T, it's just dH dt. There's no T. I mean, I guess one could say dt is a function of T, but then dt by dt is just equal to 1, okay? Now, let's talk about, though, how each of these branches, the yellow term, blue term, and this rainbow sparkly term, what those are all describing. Well, the yellow branch, everyone, right? H is a function of x is a function of t. This is going to talk about kind of like x is the horizontal displacement, right? So this is kind of like the east-west movement of the bison, the east-west movement of the bison, okay? That's dx dt. The blue branch here, this blue branch right here, okay, this is dh dt by way of y. So this is going to be the north-south movement of the bison. So you've got the east-west, or I'm looking at this, I just caught this word latitude. The latitude movement of the bison, the longitude movement of the bison, and then we've got just the temperature by way of just time, right? So if you think about this, right, how is again, the yellow branches, how is the air temperature changing as a function of its latitude movement? How is the air temperature changing for the bison as a function of its longitude movement? And then how is the bison's air changing as a just function of time in general? Okay, well, the rising sun, there's a statement here. The sun says, as time passes, the sun rises in the sky, sending out more heat. Well, that to me is described by this term right here, right? The change in time, okay? The coming cold front. I think that's just the most stupidest question, because the cold front blows in from the east, right? So the cold front blows in from the east. I would argue that that could be one of two options, because the cold front, as time passes, the sun rises in the sky, but also a cold front blows in from the east. So the coming cold front, I would argue, I would accept either this term, or I would accept to be this term, because depending also, if the cold front is blowing in from the east, if your bison is traveling easterly, then it's going to get colder, right? So I would argue in that case, it's a pretty vague, it's like I'd say that there's some vagary there. The bison's change in latitude. Latitude is east-west. Well, that is for sure this term right here, the change in latitude. Okay, I wonder if the textbook meant to say the coming cold front, like the coming cold front from the north. I wonder if it meant to say that, because then it would be this blue term. But again, I'm just reading the question literally. Okay, so that's an example of a word problem. Let's do a little bit more let's do a juicy one. You ready? This is a juicy one, everyone, and I mean juicy. And in fact, you know what? I'm gonna say I would like you to try this one for homework. I'm gonna put it on part of homework. 29 and 30. Ooh, these are tricky. All right. So here, just be careful. I'm gonna give you a couple hints. You have z as a function of x and y, right? So z, you're told z is a function of x and y, okay? X is a function of u and v. X is a function of u and v, and y is a function of u and v, okay? Now, when you're asked for this question, the partial derivative of z with respect to u at 1 comma 2, it's going to help you to remember that if I want to describe the function z in function notation, I would do this, everyone. Z is a function of x and y, but it's a function of x, which is a function of u and v, and y, which is a function of u and v. Okay, so let me give you that as your hint. Think about just what it means if you're looking at z of 1 and 2. I guess I'm just going to give it away to you. This means f is then a function of, right? So just be careful here, okay? And then see if you can get to this particular partial derivative, all right? All right, go ahead and now attempt the homework that I put on Canvas. Okay, goodbye.